Right now, someone's sleeping warmer than you are, and they're doing it without paying a single utility bill. No electricity, no gas. These people have figured out heating solutions so clever that survival experts are taking notes. And the methods they use, most of them cost absolutely nothing. The assumption is that staying warm requires money, that you need a thermostat, a power grid, or at least access to modern infrastructure. But thousands of people prove that wrong every single winter. And they're doing it with materials you probably threw away yesterday. Let's start with something sitting in your recycling bin right now. Cardboard boxes, specifically those corrugated ones with the wavy layer sandwiched between flat sheets. That wavy middle section isn't just structural support, it's an air trapping machine. And trapped air happens to be one of nature's best insulators. 3 layers of flattened cardboard placed under a sleeping area can raise the temperature someone feels by 10 to 15 degrees. That's not a minor difference. That's the gap between a brutal night and a survivable one. But understanding which cardboard matters separates people who know what they're doing from those still learning. Appliance boxes are the gold standard. Refrigerator boxes, washing machine packaging, anything that shipped something large and heavy. The cardboard is thicker, denser. People who have spent years on the streets recognize good cardboard from a block away. They'll guard a quality refrigerator box with surprising intensity because finding another one isn't guaranteed. Timing becomes crucial. Grocery stores receive deliveries on specific days. Those who pay attention know exactly when fresh, dry cardboard appears behind Whole Foods or Target. The material has to be dry. Moisture destroys cardboard's insulating ability almost instantly. Worse than that, wet cardboard grows mold within days. Breathing mold spores while you sleep creates respiratory problems that compound every other challenge someone faces. So the veterans developed a solution. They create cardboard sandwiches. A layer of plastic sheeting goes between cardboard layers, blocking ground moisture from wicking upward. Some people build entire modular systems this way. Walls, floors, even ceilings made from carefully layered cardboard and plastic. The goal is maximizing dead air space while keeping everything dry. But cardboard only traps heat. It doesn't reflect it. And your body is constantly radiating warmth in all directions. That's where another material enters the equation. Mylar sheets weigh almost nothing. What most people don't realize is these flimsy sheets reflect up to 90% of your body heat straight back at you. Some folks don't just wrap themselves in Mylar. They line their cardboard walls with it. What was basically an insulated box becomes a radiant heat chamber. Your body warms the air, the Mylar bounces that warmth back, and suddenly you're experiencing a feedback loop of retained heat. There's a problem though. Your body releases moisture constantly while you sleep. That moisture hits the Mylar, can't escape, and now everything's wet. The solution requires leaving a small ventilation gap somewhere. Just enough airflow to let moisture escape while keeping most heat trapped inside. Where do people even find Mylar blankets? Hospitals discard thousands weekly. They're single patient use items. Once used, they go straight into medical waste streams. That waste has accidentally become a supply line for people trying not to freeze. The blankets are also loud. Every movement sounds like someone aggressively opening a chip bag. That noise becomes a security issue when you're trying to stay hidden at night. But Mylar's effectiveness outweighs its drawbacks. Combined with cardboard insulation, these two materials create a shelter system that genuinely retains heat. No power source required. No ongoing fuel costs. The next level involves actually generating heat instead of just trapping it. Those disposable hand warmers sold at gas stations and sporting goods stores aren't just comfort items. They're survival tools disguised as convenience products. The chemistry is straightforward. Iron powder meets oxygen. Oxidation occurs. Heat releases as a byproduct. It's the same reaction that rusts metal, except contained and accelerated. These packets reach temperatures around 158 degrees Fahrenheit, hot enough to cause burns if placed directly against skin. They maintain heat output for 8 to 10 hours straight. Churches and warming centers distribute roughly 2 million of these across America every winter. That's significant heat generation from something that fits in your pocket. Strategic placement matters more than quantity. The instinct is stuffing them in gloves or boots, but your body prioritizes keeping your core warm. Working with that biological priority makes more sense than fighting it. Tucking warmers near major arteries, your wrists, neck, or inner thighs, allows blood to carry that warmth throughout your entire system. Heating your hands might feel nice, but heating your blood warms everything. What separates experimentation from expertise is understanding how these methods layer together. Some folks resurrect spent hand warmers using cat litter. Sounds bizarre until you understand the chemistry. The oxidation reaction stops when moisture accumulates inside the packet. Bury those dead warmers in fresh litter overnight. The crystals absorb that excess moisture. Next morning, you've got a functional warmer again. Burns may be half as long as a fresh one, but that's still 3 or 4 hours of free heat. There's another heat generation method that requires nothing but fire and patience. Terracotta flower pots become radiant heaters when placed over candles. Flip one upside down over 4 tea light candles. The clay absorbs heat from the flames, then releases it slowly as infrared radiation. This isn't heating air, it's warming objects and people directly. Similar principle to those expensive ceramic space heaters, except this version costs maybe $3 total. Dollar stores sell tea lights at 25 for a buck. Running 4 candles simultaneously costs about 10 cents per hour. The clay acts like a thermal battery. Tea lights burn around 1,000 degrees at the flame tip. Most of that heat normally rises straight up and vanishes into the atmosphere. The pot captures it, stores it temporarily, then radiates it outward in all directions. Temperature increases inside a small shelter can hit 10 to 20 degrees from this simple setup. Veterans of street living discovered something crucial though. You need to crack the pot slightly. A small intentional fracture creates airflow. Without it, the candles suffocate on their own carbon dioxide within minutes. The flame needs fresh oxygen continuously. That hairline crack solves the problem completely. Fire risk is real. These candles cannot stay burning while you sleep. One accidental kick sends flaming wax across cardboard and mylar. Your shelter becomes an inferno in seconds. The flower pot method only works while you're awake and monitoring, which brings up a question. What about heat sources you can safely use overnight? Rocks heated in fire hold warmth for 6 to 8 hours. Dense stones become nature's rechargeable batteries. Humans figured this out before recorded history. The technique is genuinely ancient. Not all rocks work though. River rocks are dangerous. Those smooth stones from creek beds contain microscopic moisture pockets. Heat that trapped water and pressure builds rapidly. The rock explodes. Shrapnel flies through your shelter at high velocity. Nobody wants geology lessons delivered that violently. The stones you need are dense, completely dry, and roughly fist-sized. Granite works beautifully. Basalt is even better. These volcanic rocks hold temperature like they're personally insulted by cold. Sandstone and limestone cool too quickly. Some long-term rough sleepers maintain what they call rock gardens near fire pits. Stones specifically selected and tested for heat retention properties. Zero ongoing fuel cost. Heat your rocks during evening hours when you're awake. Let them work through the night. Simple. But rocks cool eventually. You can't exactly reheat them at 3 in the morning, unless you're willing to get creative with truly unconventional heat sources. Decomposition generates heat. Serious heat. Active compost piles reach 120 to 160 degrees at their core, hotter than most hot tubs. Some homeless camps near farms or landscaping operations build sleeping platforms beside these organic furnaces. The biology is straightforward. Bacteria breaking down plant matter release heat as metabolic waste. Same reason piles of wet leaves steam on cold mornings. A 3-foot pile of grass clippings mixed with food scraps pumps out warmth for 2 to 3 weeks. No matches required. Just controlled decay doing what decay does. The ratio matters significantly. Roughly 30 parts carbon material to 1 part nitrogen creates optimal sustained heat. Too much nitrogen burns hot but fast. Too much carbon produces cold, slow breakdown. The downsides are obvious. Smell, insects, disease vectors. You're sleeping beside a giant bacterial reactor. Going underground eliminates many heating problems entirely. Dig past the frost line and Earth stays around 55 degrees year-round. Doesn't matter what's happening on the surface. The ground maintains equilibrium. Las Vegas has communities living beneath the Strip. Flood tunnels house hundreds of people. They've established actual neighborhoods down there. Furniture, artwork, social structures, all underground, no heating required. The Earth provides stable temperature automatically. New York has its mole people. Moscow has tunnel dwellers from Soviet times. These aren't random hideouts, they're functioning communities. Flash floods present the major risk. Those Las Vegas tunnels are storm drains. Monsoon season sends water rushing through with minimal warning. People have drowned in spaces that were bone dry an hour earlier. Veteran tunnel dwellers study airflow patterns carefully. They position themselves between entrances to maintain constant fresh air circulation through natural convection. The most overlooked heating method costs nothing. Other people. Your body generates 100 watts continuously. Put 4 people in tight quarters, and you've created a 400-watt heater that never depletes. Shelter temperatures jump 15 to 25 degrees from combined body heat alone. No fuel, no fire risk, just biology functioning as designed. Dogs function as living heaters too. Canine body temperature runs 101 degrees, warmer than humans. The buddy system serves another purpose that goes beyond warmth. Someone monitors for threats throughout the night. They watch for authorities who might force relocation. They listen for predators, both animal and human. Rotating shifts happen naturally when survival depends on constant vigilance. Research on disaster survivors confirms this with hard data. Clustered sleeping reduces hypothermia deaths by 40% compared to solo sleepers. That's not marginal improvement. That's life versus death statistics. 2 soda cans become a functional stove. Cut bottoms off both. Fit them together like nested shells. Punch holes around the rim for airflow. You've constructed an alcohol burner weighing under an ounce. This design generates enough heat to warm hands, boil water, and raise shelter temperature noticeably. 20 to 30 minutes of burn time from one fill. Fuel sources are surprisingly accessible. Hand sanitizer functions perfectly. Rubbing alcohol works. Heat fuel additive from automotive stores burns clean and hot. Most options cost under $5 and last weeks. The design originated with Appalachian Trail thru hikers obsessed with weight reduction. Someone realized 2 aluminum cans could replace expensive camping stoves. Knowledge spread through homeless networks rapidly. 1 ounce of denatured alcohol produces roughly 600 BTUs. Won't heat a warehouse, but in tent-sized spaces, the difference registers immediately. The sun costs nothing, and people figured out how to capture it. Black plastic bags filled with water reach temperatures above 100 degrees after afternoon sun exposure. Place several heated water bags inside your shelter before sunset. Water retains thermal energy remarkably well. A single gallon heated to 100 degrees contains enough power to warm small spaces for hours. Basically, your grandmother's hot water bottle, except solar-powered. South-facing shelter openings covered with clear plastic create greenhouse effects that function even on freezing days. Sunlight passes through, warms interior surfaces, heat gets trapped. Guys rig these systems using trash bags and duct tape. Aesthetically terrible, functionally solid. Those reflective windshield shades people discard every summer become valuable technology. Position them to bounce additional sunlight onto water bags. You've accelerated heating by 30% or more. Cloudy days destroy the entire solar strategy. 1 overcast afternoon transforms hot water bags into cold ones. Seattle or Portland make this method unreliable half the year. Experienced folks never depend on solar exclusively. They treat it as supplemental heat when weather cooperates. Stack multiple advantages rather than betting everything on one approach. Crumpled newspaper stuffed inside jackets performs almost as well as light sweaters. Homeless veterans call this bumming up. Layering newspapers between blankets creates dead air pockets that dramatically reduce heat loss. Same principle behind double-pane windows. Except this version costs $0. A full Sunday newspaper provides enough material to insulate sleeping bag foot areas and most torso sections. Considerable warmth from something people discard daily. Ink transfers though, skin turns gray, clothes accumulate stains. Visible evidence broadcasts exactly what you've been doing. Libraries distribute yesterday's papers freely. Coffee shops do the same. Makes this one of the most consistently available resources in any urban environment. Rain or shine, someone somewhere is throwing out newspapers. Depression-era hobos practiced this throughout the 1930s. They called newspaper insulation California blankets. Darkly humorous given the circumstances, but humor helps people cope with harsh realities. Wind multiplies cold brutally. At 35 degrees with 20-mile-per-hour breeze, your body loses heat as if experiencing 15 degrees. 20-degree penalty purely from air movement. Blocking wind essentially creates free heating. Single plastic sheets wrapped around shelters stop convective heat loss almost entirely. Body warmth stays where you generate it instead of getting stripped away by every gust. Construction sites discard usable tarps and plastic sheeting constantly. Workers tear small holes and throw away entire sheets. Waste becomes survival equipment. Seal shelters too tight and you'll wake soaked. Breath and body moisture release continuously through the night. Without ventilation gaps, that water condenses on cold plastic and drips back onto bedding. Clear plastic outperforms opaque versions significantly. Sunlight penetrates, heats interior contents, warmth gets trapped. You're constructing tiny passive solar heaters from garbage. Smart positioning matters tremendously. Place shelter entrances away from prevailing winds. Build L-shaped windbreak walls using additional tarps or debris. Wind hits barriers, deflects around them, never reaches main structures. Church outreach workers report seeing 3-layer barrier systems. Ground tarp, shelter walls, outer windbreak. Each layer adds protection incrementally. All this wind blocking enables the next survival method, something everyone carries without recognizing its thermal potential. Your own clothing becomes the final piece of the warming puzzle when used correctly. Layering strategies separate those who make it through winter from those who don't. The difference isn't expensive gear. It's understanding how fabric, air gaps, and body heat interact. What comes next explains why some people wearing $50 worth of thrift store clothes stay warmer than others wearing $300 outdoor equipment. Multiple thin layers outperform single thick garments consistently. Air gaps between fabrics matter more than fabric thickness itself. $3 store fleece throws stacked properly beat $100 sleeping bags regularly. Street veterans understand this instinctively. Core layering follows specific patterns. Base layer wicks moisture away from skin. Synthetic materials work best here. Cotton kills in winter conditions. Middle insulation layer traps warm air in small pockets. Fleece, wool, even multiple t-shirts accomplish this effectively. Outer shell blocks wind and precipitation. Even cheap rain poncho over everything else makes dramatic difference. But here's what separates survivors from casualties. Extremities receive priority attention. Lose 30% of body heat through hands and feet combined. Another 20% escapes through your head. Basic math says protecting these areas matters more than adding another torso layer. Sock strategy gets surprisingly technical. Thin synthetic sock goes directly against skin, wicks sweat away immediately. Thick wool sock goes over that, creates insulation layer. Some folks add plastic bag between the 2 layers. Sounds ridiculous. Works phenomenally well. Waterproof barrier keeps feet dry regardless of external conditions. Hands require similar attention. Fingerless gloves underneath regular gloves. 2-layer system allows removing outer layer for tasks requiring dexterity while maintaining baseline warmth. Mittens beat gloves thermally. Fingers together generate more collective heat than separated digits. Head covering makes or breaks cold weather survival. Thin beanie underneath thick winter hat creates same air gap principle. Some people wrap scarves around their heads underneath hats. Looks absurd, saves lives regularly. Thrift stores become strategic shopping locations. Experienced folks know donation schedules. Tuesday mornings often bring fresh inventory. 50 cents buys wool sweaters that cost $80 retail. $5 winter coats perform identically to $200 versions when layered correctly. Sizing matters differently in survival contexts. Slightly oversized outer layers accommodate multiple inner layers while maintaining air gaps. Tight clothing compresses insulation, reduces effectiveness significantly. Room for layering beats fitted appearance every time. Movement generates heat, but also moisture. Sweat becomes dangerous in freezing conditions. Wet clothing loses insulation value rapidly. Smart layering means adjusting throughout the day. Remove layers before sweating starts. Add them back before shivering begins. Constant calibration keeps you in the sweet spot. Some folks carry entire wardrobes in backpacks. 7 shirts, 4 pairs of pants, 5 jackets. Wet clothes get cycled out. Dry replacements go on immediately. Having backup options prevents hypothermia during unexpected weather changes. Wear your cleanest, driest layers to bed. Damp or dirty clothing goes underneath sleeping bag as additional ground insulation. Body heat dries slightly moist items overnight, while you stay warm in dry layers above. Plastic bags serve multiple purposes beyond foot protection. Large trash bags with head and arm holes become emergency ponchos. Vapor barriers worn over base layers trap heat while blocking wind. Extremely effective when temperatures plummet. Duct tape repairs everything. Ripped jacket sleeves get sealed. Torn gloves get patched. Holes in socks get covered. One roll lasts months and prevents replacing entire garments. Street wisdom says duct tape ranks second only to water in survival priority. Staying dry matters more than staying warm initially. Wet hypothermia kills faster than dry cold exposure. Protect clothing from precipitation aggressively. Plastic sheeting over sleeping areas. Waterproof stuff sacks for spare clothes. Everything stored elevated off potentially wet ground. Boot selection follows counterintuitive logic. Waterproof boots trap moisture inside from sweat. Non-waterproof boots allow feet to breathe but get wet externally. Solution involves wearing bread bags over socks inside non-waterproof boots. Feet stay dry. Boots can dry out. Color choices affect survival probability. Dark clothing absorbs solar radiation better during daytime. Creates passive warming from sunlight. Bright colors increase visibility to drivers and potential helpers. Most experienced folks wear dark base layers with bright outer shells. Warmth plus safety. Layering extends beyond clothing into sleeping systems. Cardboard underneath sleeping bag. Blankets over top. Emergency bivy sack outermost layer. Each addition traps more heat. 5-layer sleeping system keeps people alive in temperatures that would kill them in 2-layer setups. Rotation prevents wear patterns. Alternate which jacket serves as outer shell daily. Distribute stress across multiple garments. Makes everything last longer. Community knowledge sharing accelerates survival learning. Veteran rough sleepers teach newcomers layering techniques. Information passes through camps faster than through official channels. Churches and outreach programs provide winter gear but often misunderstand needs. Donating one expensive coat helps less than donating 3 cheap layers. Volume matters more than quality in layering strategies. $10 fleece pullover worn under $15 windbreaker outperforms single $50 jacket. Body heat management becomes full-time occupation during winter. Adding layers before cold penetrates. Removing layers before sweat accumulates. Active temperature regulation rather than passive acceptance of conditions. Understanding these layering principles explains why some people wearing apparently inadequate clothing survive, while others wearing seemingly better gear don't. Not about individual garment quality. About system design and strategic deployment of available resources. Survival knowledge accumulated over generations gets refined and passed forward continuously. Each winter teaches new lessons. Each lesson gets incorporated into collective wisdom. Modern street survival represents hundreds of years of trial, error, and hard-won understanding. Now you know why that person wearing 5 mismatched jackets isn't confused about fashion. They're engineering a thermal management system using whatever materials circumstances provided. These heating methods work because they follow fundamental physics. Trap air, reflect radiation, generate metabolic warmth, block convection, layer strategically. Nothing here requires advanced technology or significant money, just understanding how heat behaves and refusing to accept freezing as inevitable. The people using these techniques aren't doing it for fun. They're doing it because circumstances left them no alternatives. But the ingenuity involved deserves recognition. Turning cardboard into insulation systems, converting Mylar into radiant barriers, transforming rocks into overnight heaters. That's problem solving under pressure. What's remarkable is how many of these solutions overlap with expensive outdoor gear principles. Your $200 sleeping bag uses trapped air for insulation, same as cardboard. Your fancy space blanket reflects body heat, same as Mylar. Your thermal underwear creates air gaps, same as newspaper layering. The difference is packaging and price tags. These methods prove you can generate and retain meaningful warmth with almost nothing. The knowledge exists. The materials are available. What's often missing is just understanding how the pieces fit together. Nobody should need these techniques. Adequate shelter ought to be baseline human provision. But until that reality exists, this knowledge saves lives. Every winter, thousands of people stay alive specifically because they learned how to manipulate cardboard, Mylar, rocks, and fabric into functional heating systems. Sometimes the smartest engineering happens in the most desperate circumstances. That's not inspiration. That's just survival doing what survival does.